Your faculty advisor, Mr. Satish Kumar, will share the recordings. I've spoken to them. They will share because I don't have access to the recordings, so they have to download and share it. They will do it. Okay, so let's just concentrate here. So in the last class, we discussed about the directions and planes. We discussed how the directions are decided and how they are represented. Okay, and similarly, we also discussed how we started discussing the planes. Okay, so here we have this two-dimensional lattice which we can represent with using translating A and B vectors as well as using these lines. So that we know. So there are different ways that this lattice could be constructed using the planes or lines. So there are different sets of planes. It is not just one unique set of planes, right? If you have, you can choose planes differently, okay, and use the planes, parallel planes to stack together to get the desired crystal structure or the lattice. Okay, so here we have a typical three-dimensional lattice. So we were discussing about this. So this is a cubic lattice, simple cubic lattice. So this cubic lattice could be constructed in different ways. Let's say this is the one way, right? You take this plane, you take this plane, okay, and then this is plane number one. Then this is plane number two, that is the parallel plane number three, then plane number four. Go on stacking these planes, just maintaining the distance between them. This is the distance between the planes. This is the distance between the planes. Maintain this distance and go on stacking the parallel planes. You will get the crystal structure like this. So this is one way of constructing this crystal structure. What is the other way? We have many other ways. For example, as we took this plane, we also can take other planes. Let me tell you, we also can take this plane. Okay, for example, we can take this plane. Okay, then this will be plane number 1, 2, 3, and go on in the vertical y-axis or in the z direction. You will get the same crystal system. Also, you can take this plane, right? So this plane also you can consider the plane which is in the back. There are other options available as such as well. Let me take that one. I'll take. Right. So we can also take this plane. Okay. So this plane. You take this plane and go on stacking it by maintaining suitable distance. So this will be the plane. So this is the distance between these two planes. Sorry, this is the distance between these two planes. Okay, so we can construct the same crystal structure using different sets of planes. So if there is a crystal structure, whether it is simple cubic or tetragonal or hexagonal or monoclinic, we'll have different sets of planes available for us to choose from to construct that particular lattice. But the thing what we have to observe here is, see, when we stack these planes, these are the parallel planes, we have to stack them to get the crystal structure. When you have to stack these parallel planes, we need to maintain some distance between these planes to get the exact crystal structure of that particular crystal. So for a given crystal, for a given particular crystal, that
Sir, in the first one, you drawn three planes, no, sir?
Yeah, yeah. No,
Those
it is
three are
different.
same, sir.
No, it is different, slightly different. I'll tell you later. You can write that way as well as this way, doesn't matter. But when we label, they get different names, different labelings.
Okay, sir.
So the
Labeling
same
will be
planes can
different,
be
but the
drawn
same
for
thing.
other crystal structures also, right?
Yes, yes, yes. Over.
Yes,
If
sir.
possible,
Yes, sir.
use
Yes,
different
sir.
colors.
Yes, sir.
Yes. Okay, fine. Then let me go back and tell. Now, see here. Let's start from here. See, this is a lattice, right? It is a lattice. You can construct this lattice using, just a minute. Yeah. You can construct this lattice using, starting from any point, then go on translating the vectors, basis vectors A and B along different directions as well as C. You get the lattice. What is the other way to generate this lattice? One way to generate this lattice is start from any point, go on translating basis vectors A, B, and C in their respective directions. What is the next other option we have to generate this lattice?
So unit cell.
Very good. Take a unit cell. Take a unit cell and go on generating this unit cell or extending this unit cell in different directions along X, Y, and Z directions. You get the same line. What is the other option? The other option is instead of taking individual basis vectors or the unit vector, we can also take the plane. Plane is a much bigger and easier version. What you have to do is plane has all the information. Then we have to go on stacking these planes at appropriate interplanar distance or maintaining the distance between the planes. We have to go on stacking these planes. Right? Okay. Now write the question. What are the different ways to construct a crystal lattice? What will you write?
Vectors, unit cells, and planes.
Translation of basis vectors. Write it clearly. Translation of basis vectors. Next is extension of unit vectors. Sorry, unit cells. Third one is.
Sir, could you please once again repeat, sir?
First one is translation of basis vectors. Second one,
Sir,
extension of unit vectors. Third one, stacking of
Extension of plane.
planes. Yes. Somebody said, sir.
sir, can you
Third
what
one,
are the
sir.
different
Ah,
sir? What are the different ways to
construct a crystal lattice.
Sir, what is the third one, sir?
Third one, stacking of planes, lattice planes.
Okay, sir. Thank you.
Sir, what is different?
Ways to construct a crystal lattice.
sir? What you said about this third point, sir? This extension of
Stacking or
lattice plane.
arranging or representing
cube.
B base, sir.
Length of the edge of the
See,
cube.
this one, this is A, this is B, this is C, because it is simple cubic. Simple
Yes,
cubic,
sir.
it has basis vector A, basis vector B, basis vector C. X naught is
A, sir.
1A. Let's write 1A.
Sir,
Okay.
here in this case, A is equals to B is equals to C, right, sir?
Yes.
Okay, sir.
Where does it intercept y axis?
E vectors, 1B.
Where does it intercept
1B.
y axis? Check properly, please. This is the direction of y. This is the
Y-axis
direction of
does
y.
not intercept, sir.
It does not intercept y
Zero,
axis.
zero
So
B.
it is no,
Zero B.
no. 0B means it would intercept here at the origin. It never intercepts. Where would it intercept? We can't say it never intercepts. We would say it intercepts at
Or
infinity.
yeah, infinity. Yes, sir.
Infinity. That is, it is parallel to y. Whenever something is parallel, we always say it is infinity. It meets at infinity. Right?
So I think
Okay.
you wrote reverse.
No. Why? This is y-axis here. Check the diagram.
It is intersecting at y, but it's not intersecting at x.
No. It is intercepting at x. See, this is x-axis, right? This is x. It is intercepting at x.
So it is parallel
Y
to
is never
YZ plane, right?
Huh?
It is parallel to YZ plane, right?
Yes. It is parallel to YZ plane. It
Okay.
intercepts at x-axis at this point, at 1A. It never intercepts y-axis. Clear?
Yes, sir.
Yes, sir.
Yes.
Okay. What about z-axis?
So infinity.
It
Yeah,
is parallel to z-axis, so it is infinity.
Infinity.
Okay. What is the next point? Take the reciprocal. And you have to express this in terms of A. Okay?
So
You
the
have
y
to
not
express this in terms
by
of
number, no,
basis
sir.
vectors. So 1 by A, infinity by B, and infinity by C. Next, take the
Sir.
reciprocal. What do you get? Yes.
The y naught and z naught may be some number, no, sir. How can we take infinite, sir?
That means it never intercepts. That is, there is no number. If it intercepts, we can take number. If it doesn't intercept, we have to take it as infinity.
Okay.
Okay. What is the next step?
So 100.
Next step, take the reciprocal. When we take the reciprocal, we get 1 by 1 here. And what is this? This is infinity. This is infinity B, infinity C. So 1 by 1, this is 0 by infinity. And this is again 0 by infinity. What do we get? 1,
0,
0. So this is 1, 0, 0 plane in the round bracket. Inside round bracket, we call this plane as 100. Next, what is this plane? Tell me
Sir,
quickly.
0, 0, 1, 0.
Very good.
0, 1.
Sir,
Yes,
sir,
go on.
can you
1 1 0.
0 1 1.
0 1.
0 1 1 sir.
0 1 1.
0 1 1.
0 1.
1 1.
Okay. Next set. This one.
1 1 1.
1 1 1
sir.
Very
1 1
good.
sir.
Okay. This one.
Sir, origin.
You choose.
0 1 1 sir.
Let this be origin.
0 1 1.
0 1 1.
0 1 1. 0 1 1.
0 1 1, sir.
Next one.
1 0 1.
0 0 1.
1 0.
0 0 1. Infinity 0.
1 1 1.
0 0 1. Infinity.
0 1 1. 0 0 1.
0 1 sir.
0 0 1. Infinity. 0 0 1.
Over. Infinity. What is that? 1 1 1 or what is that? Tell me quickly.
0 0 1.
0 0 1.
0 0.
0 0 1. Next, sir. Other
Same
options.
sir.
0
Same.
1 0. 0 1
0
0.
1
0
0.
1.
1.
1 1 1.
Next option.
1 1 1.
1 1 1 I have written. Next option.
So
1
0
0.
0 0.
0 0 0 0. Origin sir.
0 0 0. Only 3 zeros or more.
That's it sir.
Only 3.
Infinity 1.
Very good. At least say why, sir.
Why, sir?
We are trying sir.
We
are trying.
when you
We are trying.
measure a plane, first thing is we have to take its intercept, right? Right? It cannot be at the origin. Okay, here nothing is specified. We normally tend to take this as the origin. We cannot take this as origin. If at all they have given this as origin also, and this is how they have given the plane, then you have to move the origin. You can move the origin to here, right?
0
This
0
is
1.
y-axis, this is x-axis, this is z-axis. It is parallel to z. It cuts y-axis at 1, x-axis at
1 1 1
minus 1.
One,
Minus
0.
1. This is positive x-axis. Right?
Sir, can you please draw the axis?
This is negative x-axis. Right? When you draw a line and start from a point, right? Any point. This is positive. This is negative. So if you are starting from here, the normal nomenclature is positive this side, negative this side. So it is cutting or intercepting x-axis at minus 1.
Minus 1.
Right? So it should be what?
Minus 1 1 0.
1 1 0. But here we do not represent minus 1. So we represent minus 1 as We represent -1 as 1 over a bar. 1 bar 1 0. Okay. Alternatively, look here. Alternatively, what can we do? We can also choose this as origin. When you represent, you have to be careful. When you choose this as origin, x becomes positive intercept, y becomes negative intercept. In that case, what you get?
1 minus 1 0.
1 bar 0. Don't say -1. 1 bar 0. This is for this origin. Okay. And this is for this origin. Write down this quickly.
Sir, why should not we take the origin that is middle of those two, sir? Backside.
Which one?
Firstly, we choose it, sir.
This one.
Yeah,
It won't make any sense. It won't make any sense.
And how to identify that one, sir?
That's what. Use some common sense. If it cannot pass through the origin, then shift the origin whatever the way you want. Okay. You see a few more, you will understand. Now you work with this one, third one. Work with the third one and let me know.
Sir, once you please tell me that infinity 1 point, sir.
No, it is not there. It won't work.
Okay, sir.
Because you have taken x and y intercepts to be 0, you have got infinity. You cannot take x and y intercepts to be 0. Either it intercepts or...
Sir, can you please say which side is the y-axis, sir?
Y-axis is...
R1, 1 1 0.
This way. This is y.
0.
This is z.
So last one is 1 bar 0 1.
Now, where did you choose the origin? You tell me that.
Sir, the original origin, sir, towards the x-axis. Sorry, y-axis.
Y-axis.
This one?
Yes, sir.
Yes, sir.
Yeah, you can choose this one with positive y, positive z and negative
y.
Very good.
Y.
So it is 0, 1 bar
1 bar 1. 1 bar 1.
1.
What is the other alternative? Can somebody give me an alternative?
Same, the
So that
opposite side also.
which makes this one positive. If you have to make y positive, what is the alternative option?
So backside.
So you can take the z-axis as the origin.
This one.
Yes.
We can take this,
Yes.
right?
Yes, sir. Backside.
This is minus z. This is plus y. So in that case, what you get? We get 0,
0 1
0,
1 bar.
1 bar.
Very good. That's it.
So we can also take right side one.
Yes, you can take this one as well. I'm trying to move it from this point to either here or here. It is not advisable to move it here. This is by 1a.
Right side
Always
down.
it is better if you move it this way or this way. By one basis vector, you move it always. That's always better. You can choose it other way, but you have to mention. That's it. Clear?
Sir, in which direction you should take always x, y, z, sir?
See, normally, what happens. This is always z direction. There is no doubt. Okay. I prefer to take this as x. I prefer to take this as x and this as y. Okay. But in many textbooks, they consider this as x and this as y. So fix
sir, will
that.
they mention those coordinates in the diagram? Sir?
X and y, you can interchange it. But when you write, you remember, you have to mention x, y properly and then continue. It doesn't matter whether you take x along this direction or this direction. Doesn't matter.
Sir, will they mention in any question, sir, those coordinates?
Sorry?
In any question, will they mention those coordinates x,
No.
here,
They
y?
will not tell. They will not tell. They will just ask 0, 1, 1, represent 0, 1, 1. You have to write the coordinate system, represent x, y, z properly, and then mention it. Clear?
So we have
Okay,
to
that's-
write those coordinates, no, sir.
Then what then? Come on. If a diagram is given, if it is required, we would have written. If it is not required, a diagram like this would also be given, where you have to fix the coordinate, right? Like this. You have to fix the proper coordinate, Miller indices, otherwise gone.
Okay, sir.
Sir, for
Last
the
diagram,
third
can we
figure,
take
what is the x and y axis?
This is y-axis for third figure. Y-axis is always outside the plane, outside of your mobile screen or laptop screen.
Sir, then by that, going by that thing, the first diagram, I think last should be 0, 1, 1 bar, sir.